hard, of course. And yes, it really was HAProxy. Not every time. So a bit on who we are. We are Taghos Tecnologia. We are based in Brazil, so we focus on Brazilian customers. We have our own servers, such as these two in the picture. We have them in many different POPs. Most of the POPs are in Brazil, but we also have servers in a few international locations. We have our CDN product, which is SingularCDN, where we offer streaming with optional real-time video transcoding, HTTP caching with optional dedicated and guaranteed storage. We also offer some network protection against threats such as piracy and DDoS, as well as a large number of network filtering options. We also offer premium support, which is in native language, very fast, 24/7 and every day of the year, including leap years. So how exactly do we use HAProxy in our setup? This is an overview of our most common setup across our servers. Our servers are different because each new generation of hardware, we have a more powerful server, but the old fleet continues. So we will have a wide range of different CPU types, models, core counts, more or less RAM, and as well as more or less storage and faster as well. In each server, we run 2 instances of HAProxy. We run a front-end instance which is responsible for responding to client requests over the internet. And we also run a backend instance that provides internet for our services. So we only have TCP on HAProxy. Everything else goes through Unix sockets. In our stack, we use Varnish, which we have our private fork based on version 4. And we also have HyperCache, which is our own HTTP cache. And to connect everything, we use splice response a lot because we need to keep traffic amplification down to a manageable level inside the server. And how exactly does HAProxy helps us? Since it is only HAProxy that has TCP sockets, it shields all of our services from the internet. You cannot reach a service without going through HAProxy. HAProxy allows us any kinds of combination across different HTTP versions and cryptography. So our services don't need to care about that. We can use many of the filtering options that HAProxy has to offer, which includes, for now, since we roll out 2.6, we are also using JSON Web Token authorization. And being such a central place, central position in our server architecture, HAProxy is ideal to generate our access logs, which we use for billing. And by just tweaking configuration files, we can perform blue-green service rollout. So let me show you about the tools that we use in our day-to-day operation. Here is SAR. Every server runs SAR continuously. We collect everything that SAR can collect at the maximum resolution, which is 1 second. SAR it basically never fails. So in order to analyze the data, we use a set of nuplot scripts that we have implemented over the years, where we perform different analysis and correlations. This is not supposed to be real time. So we only generate these charts when we feel the need to do that. And in this picture, we have a CPU storm happening just a few moments after we reloaded HAProxy. But from other data, we were able to clear HAProxy, so it was not to blame here. For real-time analysis, we use InfluxDB and Grafana, which should be still be a popular pair. But as a data source, we implemented our own data collector, which we call Coletor. It was designed to be very lightweight and resilient, and in particular to buffer data when there is a network outage, because once you have a 24/7 service, you are bound to have network outages. We collect data that is similar to what SAR collects, but we also ingest data from other sources, such as HAProxy itself, using a stat socket, and Varnish directly from the VSL. In fact, we are limited only to what we care to implement in terms of data collection. And in this picture, we have, in this graph, we have the same time frame as before, but we have more data, and this was on real-time analysis. So on the middle dashboard, we have the CPU storm. There's the dashboard for CPU usage. At the bottom dashboard, we have the impacts on the network interface, which was happily transmitting at about 70 gigabits per second. Then the CPU storm came, and eventually it was able to converge back on 70 gigabits per second. And on the top dashboard, we have a load average. That was the one that quickly cleared HAProxy, because it peaked at almost 1,000. So that's not HAProxy. We don't use that many threads. We also use regular process viewers, such as here we have HTOP, originally from our good friend Hisham. Many people also use HTOP as well. HTOP provides instant feedback and make it very easy to spot weird scenarios, such as we have here. That is the eye of the storm in the previous CPU storm. So basically, every core was fully loaded, wasting time on system level. So they are not too precise, so there is some eyeballing, and you have to get familiar with how your workload looks from the perspective of this tool. And you have to be lucky, because these tools provide instant feedback. So if you are not paying attention, then you will not see anything. But still, they are very helpful in balancing NUMA, because once you are juggling your processes from CPU core to CPU core, you can instantly see the effects. So there's a lot of there are many cases for their usage. We also use Linux Perf, which these days is a huge tool. So we have to go we have to describe subcommands. Here we have perfstat, which is very lightweight. It is great for precisely comparing metrics. And that makes it excellent for balancing NUMA, because you can numerically assess how well your fit was. You can go pretty much any level, system-wide overview, all the way down to perhaps a specific CPU core, or maybe you are interested only on a specific software thread. You can do that with perfstat. It gives us many starting points and warnings, such as here we have a data collection where we focused on a single thread from HAProxy front end, where we use 35 threads. Network interface was transmitting at about 60 gigabits per second at this time. This collection lasted for 10 minutes, and we can see a very high rate of bad speculation, which means that we have a lot of work back in Brazil. PerfTop, it's instant feedback, should look similar to, if you are familiar with HTOP. PerfTop is especially useful when you are investigating load spikes, because you can throttle down your sampling frequency, so you don't finally overload your server if you are suffering from an overload. But again, it relies on experience. You have to get familiar with how your workload looks through PerfTop, Otherwise, it's just confusing. And here we have a picture, again, from the same HAProxy thread, where it's working fine. Network interface transmitting at about 67 gigabits per second. So nothing in particular happening with HAProxy. But glibc thread asynchronous cancellation points, they are very high. So this can, to our taste, it's very high. So it can mean that we do have a lot of thread contention, but it could be a bit related to the bad speculation. So we might have a NUMA issue here. Perf record, it allows us for a much longer and complex analysis. We can pipeline the data into other applications. The most famous would be Brendan Gregg's flame graph, which we have here. This is a system-wide collection, data collection. So we collected data from 71 seconds. Network interface was transmitting at about 67 gigabits per second again. And we tuned down frequency to 97 hertz and generating this beautiful, if not confusing, flame graph, where we highlighted HAProxy. It's the only bar in magenta at the lower left, or here. It is accounting for about 12% of the call stacks, which when we mention a perfect record, it is combining both HAProxy front-end and back-end, because it's just the command name. And when we do this kind of data captures, we have to be careful, because this we always run on loaded servers. These are production servers. They are usually loaded, very loaded. And we are usually collecting data because there is something happening, and perhaps we are about to have an incident. So we have to be careful not to add too much pressure into the system as to finally make it saturated. So it is, we also have to perform some post-processing of the data directly on the server, because you cannot move a 200 gigabyte trace to another server when you have a situation like that. So it is very nice when you use NICE to perform your analysis. And there is a nice counterpart for perf record, which is perf script, which I expect you after the conference that you start using perf script to archive your data. Because who knows, maybe you will need to create slides for a conference, and then you have no data to revisit and generate flame graphs, and then you have to capture again. So learn from me. So I've mentioned earlier that we use splice response, and wow, how much? So this is the same flame graph as before, but we are focusing on HAProxy, so it includes front-end and back-end again. And just by eyeballing the magenta bars, you can estimate that it's about 50% of the call stacks in the system have to do with splice. So from the 12% that HAProxy was accounting on the whole system, about 6% of that is just splice. For us, that's pretty significant. Here we have perf trace. This is very new in our toolkit, because now we are rolling out newer servers, so we are rolling with newer perf as well, newer kernel and perf as well. It allows us to emulate strace, but without the overhead, which if you ever used strace, it can get pretty high. System calls are very useful in providing clues. We have a node ticket 356 where we diagnosed splice response was mishandling chunk data, and it was pretty easy to see that happening with strace. But this kind of tool, like strace and perf trace, they quickly generate a large volume of data. So you want to be very quick, and you should be lucky to catch what you are looking for quickly, in just a few tries. But we always limit the amount of events that we capture to anywhere between 1,000 and 10,000 events, because you really don't want this kind of tool to keep running straight. And we also use eBPF. We install from IOVisor, a BPF compiler collection. So eBPF provides you with extreme flexibility, but you probably will need to program a probe, which is not difficult, but it can get quite challenging, because with BPF you have restrictions. For instance, you don't have a backwards jump, so you don't have loops, but it's not too difficult to work around that. Once your probe is well tested and mature, you can leave it running for months, literally. We have done many times in the past without any issue. And eBPF makes it particularly great for analyzing peculiar issues, such as when we needed to confirm if and why was HAProxy dropping logs. Logs are logs when generating access logs. This goes for our billing, so it is quite important for us. And after a few times running with our probe collecting data, eventually it confirmed that one of the threads had dropped a log, and now we know why. It took a again return status from the kernel, so kernel probably wanted to block HAProxy. HAProxy does not want to be blocked, so the only choice was to discard that line of log, so we lost a billing point. A pain point in our experience with BCC is that sometimes, especially when you are doing very large leaps in terms of system update, you are rolling a kernel that is many versions ahead, or even if you are updating BCC after years, you might hit a API change that can break your probe, and then you have to fix it if you still care about it after so much time. So with the tools presented, most of the tools that we use, how do we find out if it really was HAProxy? Sometimes pretty easy. You just open HTOP and you can have a sense. So this was when we roll out 2.6.4. The moment we roll it out and execute it, opening HTOP for a quick inspection, we could see these long green bars. That means trouble. HAProxy does not look like that. So we could tell that there was too much CPU time being spent on user space, and it was accounted for HAProxy. The bars were uneven, so that suggests that there is also some kind of saturation. And this was at a very modest transmission rate, so 10 gigabits per second. That's not even warm up these days. And it was actually that limited because HAProxy was choking on CPU and was not being able to make progress on transmitting data. So we collected data from perf record, which it's pretty much our first approach. We noticed a hot call stack that we were not used to see in our servers, but because perf record data is so low level, we were not able to make sense of it. So we asked for help, so we were not able to find out what was wrong. We filed a ticket, and we included as much data as we knew how to gather. And we quickly asked us about show profiling data. This was new to us. We had not used by then. So we collected data for Willy, and in fact, there were a couple of functions that were way too hot in HAProxy, so we informed him. And through discussions over the tickets, Willy was eventually able to bisect this problem to a specific commit that was on 2.6 that landed on 2.4.16. The 2.4.16 did not hit us because we were still on 15. Only the 2.6 instance was facing this issue, and he quickly provided a patch, which we confirmed as working, and case closed. So, but in this scenario, it became evident for us that we should always keep the previous HAProxy setup binaries and configuration files ready to run at a moment's notice, I mean like seconds, because we needed to roll back and forth quite a few times when we were investigating this issue. So a few weeks later, after the ticket was closed, we decided to randomly reproduce the measurements. So we chose, of course, it has to be a peak time because we have to be confident in what we are doing. So we go for the peak hour, and we repeated data collections for a set profiling task 3 times. These were longer collections. They were like 3 minutes long. Network interface was operating high, but not too high, so 58 gigabits per second in transmission, which means mostly HAProxy front end, and receiving at about 4 gigabits per second, so that's pretty much HAProxy backend. And in 2 of these data collections, it was very clear from data from SAR, which is these graphs, where we have collected data, and we could tell to the second when we started and stopped, because there was these disturbances, but only on the first 2 data collections, not on the third. When we analyzed the graph for packets per second, we noticed that the disturbance was high, but not too crazy high. But in our setup, the data coming from HAProxy backend gets amplified on the front end. So at that time, we had about 26,000 sessions. So that was enough to really escalate the variation. And we even have these blue dots around. Those are packet drops. And these disturbances and packet drops happen only during the time that we were collecting data with set profiling tasks. But literally last week, we noticed that we have data to show that kswapd from Linux kernel was way too active during the peak, which included the moment that we performed these data collections. So to us, it always serves as a reminder in how hard it is to really to truly find the root cause once you have so many variables at play. So here's another case. Our servers are usually loaded, and we were in the process of rolling out a new service. And totally by chance, someone in the team noticed, oh, there are some HAProxy backend instances still running, and they are spinning on CPU. So they were fully loaded on their specific cores. And of course, we collected data from perf. We noticed a specific hot function. So at the time, we quickly filed a ticket. At that time, we didn't know about set profiling tasks, so we had less data. But from perf report annotate, it was pretty easy to notice that there was indeed a hot loop, and it was a contended loop. So we had a hot loop with threads, which makes sense. So because our config file has 600 more than 600 backends, we use threads, and this was on DNS resolver code. We got a suggestion in the ticket, in the GitHub ticket, to use more resolvers as a means to distribute the thread contention. And we did that. So we quickly implemented a post path, which takes the configuration file and For each backend, it will assign a random DNS resolver. By the time we deployed this, we never heard of this issue anymore. There is a proposed fix in the ticket from Christopher, but we have difficulties in confirming it because we need green light from our ops, and they are reluctant to let us revert the configuration file, which might expose clients to the issue. So we are still looking for perhaps a better way, maybe a regression test here. And here's the last one, very recent case, still open, and even more complicated for us. So we roll out 265. Usually our HAProxy instances are reloaded many times per day, both front-end and back-end. And what we normally expect is that when we are gracefully reloading the front-end, that the previous instance will simply stop accepting new connections, because the new instance is supposed to take over and accept the new connections. The previous, the old instance did in fact stop accepting connections, but the new one did not take over, so we had a major degradation. They are not too clear on these graphs, but we have a sudden drop by the middle. That's when it becomes an incident. And we had to roll back, but we also hit the same issue with 2418 and 17 in a row. So we created a ticket. We included as much data as we found relevant. This time we did not include perf record because it didn't make sense, but we did include show profiling tasks. But still, we are at a loss at what is really happening here. We have even implemented a probe, this time not an eBPF probe, but a simple C program, which does the following. It connects to HAProxy, to the stat socket, and leave the first connection idle. And then every few seconds, it tries to perform to open a second connection with the same instance in the same socket. So what we expect to eventually see is that maybe a timeout happens, and then that serves as a signal for us to send a long string of comments to the first instance, so that we can at least have some sort of state from the previous instance, what is happening, and maybe provide more information. This, since this generates such a degradation, we have to brute force to do a brute restart on HAProxy. There's no time for a graceful operation. So to recap our takeaways, throughout the years using HAProxy, our toolkit quickly evolved to a large set of tools. Some of them we use only for offline analysis, such as SAR mixed with nuplot, perf record, perf script, and flame graph. Other tools are more suitable for real-time analysis when things are hot and happening. So we use Grafana, we have alerts. HTOP is a great friend. And we also use perfstats and top, and also trace occasionally, even to confirm if splice is running. So, and we also have what we could call a reactive class of tools, where we include our probes and even the custom craft programs and scripts that we use to monitor and alert us of specific conditions. We believe that we evolved from lurkers from the mailing list into active contributors mostly through GitHub. We are frequently rolling out new releases, testing out features. We even roll out dev releases sometimes. we expose HAProxy to whatever we have. So if the server peaks at 85 gigabits per second, that's HAProxy. And of course, we use everywhere. GitHub has proved itself pretty great for interactions with the team. So it is pretty easy to keep focused on parallel discussions. So we have at least one open ticket, and we can, whenever we have data, we can just pop over there, and eventually a developer reaches back. Measuring production, always a challenge. It doesn't get any easier. And well, it really was HAProxy, but we have to be honest, it was not that often. So we are in great debt of all HAProxy developers for such a great and rock solid work. So thank you from Taghos Tecnologia. And we are open for questions if you have.
Thank you, Ricardo. Great job. So we do have a few minutes for questions here. Again, we do have microphone runners. If you have any questions, just raise your hand and they will come right over to you. And you can also submit questions in the stream, on the chat, or on Twitter, #HAProxyConf. So we did, during your talk, have a couple questions come in on the stream, so I can start with those. So this is in reference to the monitoring tools. So it sounds like your team places a high value on metrics. Was it always that way, or how did your team get better at that over time?
We had to invest a lot on telemetry. So for instance, in the past, we used Intel Snap, but in our setup, it consumed 2 CPU cores. That was way too much on a machine that had 24 CPU cores. So that's why Collector was created. It barely accounts in terms of CPU usage. It is very limited. It's extremely tailored for our cases. So it's not open, like it's just a private tool. But because we needed telemetry, we needed to survive network outages. Usually during the network outage, we lost telemetry, so that was not useful. So as the years go on, we had to invest in different tools for telemetry. And even now, we have the probe that we noticed that HAProxy did not pick up, is not accepting new connections because we lose telemetry with it. That's why we are trying to keep a idle socket, and then if we notice that we cannot connect a second time, maybe I will try the idle socket because it was connected already. So yeah, telemetry is pretty much essential.
We do have a question over here.
Not exactly a question. I would like to thank Ricardo because he's one of our few users who report extremely detailed bug reports and who never complains. So thank you, Ricardo.
Thank you.
And it's actually the last question we have time for. It's related to this point. So your story is clearly a big win for open source. What's your advice for anyone who is hesitant to get involved in open source? You mentioned going from a lurker to a contributor. So what would your advice be to people who are still the lurkers out there and hesitant to become, contribute in this way?
Put out your face. Maybe you get a slap. I did get a slap many times, many years back, not from HAProxy. Was the first time I sent a message to Linux kernel mailing list, and it was not well received. Keep going. Eventually you will get it right.
Persevere.
Yes.
Excellent. Okay, so that's all the time we have for Q&A. Again, a huge thank you to Ricardo. Thank you.
Thank you.
I can take that.